Welcome to Kanerika's podcast, The Digital Shift. Today, we're embarking on, well, a really exciting journey into the future of mobility. We're going to dive deep into edge computing in autonomous vehicles. Our mission today is to try and cut through some of the complexity, and deliver the crucial insights you need to understand why this tech isn't just interesting, but really fundamental. Fundamental to making self-driving cars safer, faster, and importantly, more reliable for all of us. To maybe set the scene a bit, think about this. It's pretty staggering. A single autonomous car can generate up to 4 terabytes of data every single day. That's just an overwhelming amount. And when lives are potentially at stake, every millisecond counts, right? Even a tiny 200 millisecond delay, literally the blink of an eye, that can be the difference between safety and, well, disaster. And this is exactly why edge computing is so pivotal. Nvidia's CEO Jensen Huang put it quite well. He said, cars are essentially supercomputers on wheels, and edge AI is what makes them intelligent enough to drive safely. It's about getting that intelligence right there, inside the vehicle itself.
Exactly. And what's really compelling, I think, about edge computing is how it fundamentally decentralizes data processing. It flips the old model. So instead of sending absolutely everything off to some distant cloud server, the processing moves much closer to the source, right inside the vehicle. And this approach, it just radically cuts down on reaction time. It delivers, not just faster responses and lower latency, but also dramatically improved reliability.
Yeah.
It's really about empowering the vehicle to make those critical, potentially life-saving decisions in real time, exactly when they're needed most.
Okay, that idea of processing data where it's created, that seems key. But maybe could you draw a clearer line for us? Is edge computing just like a faster version of the cloud? Or is it something fundamentally different, a different paradigm designed specifically for these real-time critical jobs?
That's a really crucial distinction to make. Yeah, while the cloud is absolutely brilliant for the heavy lifting, training huge AI models on massive data sets, it's like the ultimate learning library. It's just not built for those split-second decisions a car needs to make out on the road. The latency, even if it seems tiny, it's just too great when you're talking about avoiding a collision. So no, it's not just faster. It's a totally different architectural approach. What we're seeing more and more is that autonomous vehicles rely on a hybrid architecture. It's edge and cloud working together. The edge handles all the critical real-time stuff, recognizing that pedestrian, braking immediately, steering around an obstacle. While the cloud handles the longer-term things, like learning from fleet data, storing maps, pushing system updates. Maybe an example helps. Imagine you're walking and you suddenly step out into the road. An autonomous vehicle has to recognize that danger and start braking within milliseconds, literally. Now, if it relied solely on cloud processing, even a slight delay, maybe a few hundred milliseconds getting the data there and back that could cause an accident, edge computing, because it's right there in the car, it guarantees that immediate action. No waiting for external input. It's the real difference between being reactive and truly proactive safety.
Right. So if we boil it down, edge computing seems to bring these maybe 3 huge advantages that are really shaping the future of driving. First, that instantaneous decision-making, absolutely critical, like you said, for preventing accidents. Second, drastically reduced data transfer, right? Because it processes locally, it avoids just overwhelming the networks and saves costs, I imagine. And third, that unwavering reliability. The car isn't totally dependent on having a perfect connection all the time. It stays safe even if cloud access drops out for a moment.
Exactly right. And if we connect this to the bigger picture, it's also about real-time contextual awareness. Driving, it involves thousands of tiny decisions every second, often needing responses faster than 100 milliseconds. Edge computing delivers this because it's processing all that complex sensor input directly in the vehicle. It builds this incredibly detailed, up to the millisecond picture of what's happening right around the car. And that allows for really nuanced, incredibly quick reactions. And this leads nicely into another key benefit, scalability and fleet learning. It's quite clever, actually. Imagine each car developing its own sort of local wisdom based on its immediate environment and driving patterns. It processes its own data locally, makes immediate decisions, and then, this is the smart part, it only shares the refined, high-value insights back to the cloud, not the raw terabytes of data. So this creates a collective learning system. The cloud aggregates these key findings from many cars to improve the AI algorithms for the whole fleet, and then it pushes those improvements back out to the edge. So the cars stay super responsive and individual locally, but the cloud ensures this continuous global improvement over time. That kind of efficiency is just impossible with only cloud processing.
That's a really powerful point, that idea of local wisdom feeding into collective learning. It makes total sense. And I guess such a sophisticated system must need some equally advanced tech under the hood, right? What's actually making all this possible?
Well, yeah, it's quite a symphony of cutting-edge technologies working together. We're talking about incredibly powerful, dedicated AI chips and edge processors. You hear the names Nvidia Drive, Intel Mobileye, Qualcomm Snapdragon Ride. These are basically miniature supercomputers. They're capable of trillions of operations per second, turning all that raw sensor data into immediate, actionable decisions. And then complementing the hardware, you have edge AI frameworks, things like TensorArt and OpenVINO. These are specialized software toolkits that optimize the AI models so they run lightning fast and efficiently on these edge chips without using too much power. And something else that's becoming pivotal is the integration of 5G with MEC, that's multi-access edge computing. MEC puts small computing nodes even closer to the network edge, like at cell towers. This allows cars to communicate with infrastructure, think traffic lights, road sensors, even other vehicles almost instantly. This real-time info exchange, often called V2X or vehicle to everything, it's critical for making smart cities work seamlessly. Then, of course, there's IoT and sensor fusion. That's the clever bit where the car blends all the data coming in from cameras, LiDAR, radar, rain, to build a complete, accurate 3D picture of its surroundings, identifying everything from a kid's ball rolling into the street to another car changing lanes unexpectedly. And all of this complex orchestration, it's managed by sophisticated vehicle operating systems and middleware. Platforms like ROS2 or AutoSAR Adaptive, they're the software brains ensuring all these systems work together smoothly and crucially securely. And finally, you absolutely need robust security layers. Edge firewalls, encryption, protecting against cyber threats is paramount.
Okay, so we've talked concepts, we've talked tech, but what really brings it home, for me anyway, is seeing it actually working. Can you maybe walk us through some real-world examples? Where is edge computing already making autonomous vehicles safer right now?
Oh, absolutely. Good examples are everywhere now. Think about Tesla's Autopilot and their full self-driving or FSD system. Those cars process camera and sensor data directly inside the vehicle. That's for the instant reactions to road conditions, hazards, other cars. Then they send anonymized, the high-value summary data back to Tesla's cloud for that fleet learning and model refinement we talked about. Then you have Waymo. Their vehicles use edge systems to recognize pedestrians, cyclists, other vehicles in milliseconds. They predict their movements and react instantly. Their car's processing just massive amounts of sensor data locally to create this incredibly detailed, real-time map of their environment. And it's not just the newer tech companies. Even established automakers like GM with Cruise and Ford with their former Argo AI venture, they've used hybrid models, handling those immediate safety decisions right there on the edge locally, while using cloud systems for broader things like navigation, map updates, optimizing traffic flow. Look at China. Baidu Apollo is a huge player there. They combine edge computing with 5G to create these really connected car ecosystems in smart cities. They're optimizing traffic flow, reducing congestion, improving overall efficiency through that constant low latency chat between vehicles and the city's infrastructure. And yeah, back to the hardware like we mentioned, Nvidia's Drive Orin chip. It's a prime example of a powerful edge processor, processing over 254 trillion operations per second, responding to obstacles in well under 100 milliseconds. So yeah, these aren't just lab experiments. These systems are actively making roads safer today.
It's really clear from those examples, isn't it? Edge computing isn't just theoretical anymore. It's actively shaping the roads we're driving on. And seeing that kind of real-world impact must be incredibly exciting for companies working right at the forefront of this technology.
Absolutely. And, at Kanerika, that's exactly what we're passionate about. We focus on translating these cutting-edge innovations into practical, valuable solutions for businesses. Our deep expertise in data and AI really positions us well to deliver these tailored solutions. Whether a client needs generative AI or predictive AI, or like we're discussing, edge AI, we build based on their specific requirements. We don't just, implement AI for the sake of it. We work hard to make sure it aligns directly with our clients' business goals, delivering measurable results and helping them harness these advanced capabilities.
That makes sense. But while the promise is obviously huge, we should probably also be realistic about the road ahead. I mean, like with any transformative tech, there are bound to be significant challenges to navigate, right?
Oh, definitely. That's a critical area to consider. On the hardware side, for instance, hardware costs are still substantial. Equipping vehicles with these really high-performance edge processors, plus all the sophisticated sensors, it adds a lot to the manufacturing price, and that eventually impacts the consumer. Then there's the issue of heat and power consumption. These processors, running trillions of operations a second, they demand significant power and they generate a lot of heat. So you need really efficient cooling systems, but ones that don't drain electric vehicle batteries too quickly or add too much weight and complexity. It's a tricky balance.
And thinking beyond the hardware, I've heard some discussion, maybe devil's advocate here, that as networks like 5G and eventually 6G get really mature, with all that bandwidth and super low latency, maybe the absolute need for such heavy edge processing might lessen. Could we rely more on a super fast cloud connection?
That's a really valid point, and it is part of the ongoing discussion in the industry. While future networks will undoubtedly get much better, faster, lower latency, it's probably unlikely they'll completely eliminate the need for edge computing in autonomous driving. And there are maybe two main reasons for that. First is just guaranteed availability. You simply cannot rely on having perfect 5G or 6G coverage everywhere, all the time, in every single situation. Think tunnels, remote rural areas, maybe even just network congestion in a busy city. A self-driving car cannot afford to lose its critical decision-making ability even for a split second. Edge processing provides that essential fail-safe. And the second reason, touching on something we mentioned earlier, is security. This becomes an even bigger deal. Because edge computing processes sensitive data locally, each vehicle becomes a potential direct target for quite sophisticated cyber attacks. So ensuring really strong encryption, intrusion detection systems, secure ways to update the software, that's absolutely essential for protecting fleets of autonomous vehicles. Otherwise, hackers could potentially manipulate the car's decision-making or steal personal data. The more intelligence you distribute to the edge, the wider the potential attack surface becomes. And there are other significant hurdles, too. Standardization issues, for one. This whole autonomous vehicle ecosystem involves so many different players, automakers, tech companies, infrastructure providers. And right now, there's a bit of a lack of universal agreed upon protocols for things like V2X communication and how edge systems integrate. Without strong industry-wide standards, getting different systems to work together seamlessly, interoperability becomes really difficult, and that can slow down large-scale deployment and that smart city vision. And finally, there's this nuanced challenge of, let's call it, hybrid scalability. We know the cloud is great for training those huge AI models. The edge excels at doing the real-time thinking, the inference, managing that delicate balance effectively across potentially thousands or even millions of vehicles. That's incredibly complex. It requires really sophisticated hybrid strategies. Edge devices handle the immediate, split-second tasks, constantly learning locally, while the cloud systems aggregate all that learning to update and retrain the models for the whole fleet. It's this continuous, dynamic loop that needs robust management and ongoing optimization.
Yeah, it definitely sounds like a tightrope walk, balancing incredible potential processing power with the very real constraints of a moving vehicle and this whole complex ecosystem. But looking past those challenges, the future for edge computing and autonomous driving seems incredibly bright. I mean, potentially revolutionary, right?
Absolutely. The vision is really for the seamless convergence, smart computing, hyperlocal processing right in the car, and these ultra-fast networks like 5G and down the road, 6G. This combination will allow cars to essentially think independently, almost intuitively reacting to their surroundings, yet stay deeply connected to their environment and other vehicles. Vehicles really are evolving into data centers on wheels. They'll be capable of processing massive amounts of information, running multiple complex apps simultaneously, everything from advanced predictive navigation to highly personalized entertainment.
And crucially, as you mentioned, edge computing seems absolutely essential for getting to that ultimate goal, Level 5 autonomy, where cars can drive completely without any human input at all, under any conditions. That's not just about convenience, is it? It unlocks entirely new ways of thinking about transportation.
Exactly. And industry forecasts, you look at reports from Gartner, McKinsey, they predict edge computing will be standard in most new vehicles by 2030. This will enable completely new business models, think widespread autonomous taxi services, super efficient smart delivery robots, truly personalized mobility on demand. Billions, literally billions, will be invested globally in building out this infrastructure. And beyond the business side, there are significant environmental benefits too. Processing data locally reduces the need for massive data transmission, which saves substantial energy. That contributes to greener transportation. The long-term vision. It involves global fleets of cars that learn collectively, sharing insights via the cloud, while maintaining that instant local responsiveness at the edge, creating smarter, safer, and much more efficient transportation systems that really benefit everyone, individuals, cities, the planet.
Wow. So today we've really explored how edge computing isn't just some minor upgrade. It's actually the foundational intelligence that's driving this whole autonomous vehicle revolution forward. From those life-saving instant braking decisions to the collective fleet learning that constantly refines how smart these vehicles are, It's fundamentally reshaping how vehicles perceive, react, and learn.
The implications are just profound for safety, for efficiency, for the very nature of how we get around. And as I mentioned, we at Kanerika truly believe in empowering businesses to harness these advanced capabilities. We really invite listeners to explore how we can help transform their business with our efficient edge AI implementation services. Partnering with Kanerika today can help future-proof your AI strategy with scalable cloud and edge solutions, all built for measurable success and real-world impact.
It really makes you think, doesn't it? What new possibilities will truly open up when every single vehicle on the road becomes a real-time, intelligent decision maker, collaborating with its environment with other vehicles to create a genuinely seamless and safe mobility ecosystem. This is definitely a thought to ponder as we continue here on The Digital Shift.